Welcome to Mastering Solutions. Let's start this problem by making a list of what we're given. We need to figure out what is the first order diffraction angle. So that is going to be theta. That's what we're trying to solve for ultimately. If they say first order, then that means m in this question will be 1. And our d, or the slit spacing, in this case the lines of the melanin, is 2 microns apart. So 2 times 10 to the negative 6 meters is going to be d. And then lambda, in this case, is for green light, and that is 550 times 10 to the negative 9 meters, 4 nanometers. So what is the equation that we'll be using? We're going to be using sine of theta is equal to m times lambda over d. Now, to isolate theta, we've done this in a lot of the previous questions. We just take the inverse sine, of course. So inverse sine times m lambda over d, and that will give us our theta. And we have everything, so let's plug it in and find this out. So the inverse sine of m is 1. Lambda, we said, is 550 times 10 to the negative 9 meters. And d, in this case, is 2 times 10 to the negative 6 meters. So when we go to our calculator, we have the inverse sine of 1 times 550 times 10 to the negative 9, and then that's divided by 2 times 10 to the negative 6. So my calculator is in degree mode. So in degrees, that is going to be 15.96 degrees or 16 degrees. But for practice, let's convert this to radians. So we have 15.96 degrees. And in every 180 degrees, there are pi radians. So the degrees will cancel, and we have 15.96 times pi over 180, and that gives us 0.278 rads, 0.278 radians. Now, if you forget how to do that on a test, the way that you can do it in the calculator is a couple ways. One, let's take our question up here and just change it to radian mode. So that gives us 0.2785. I guess we could have rounded that 0.279. Or if you forget to change it in radian mode and you're like, I only have degree mode. And let's say you forget that you can just put it in degree mode. Another way that you can do it on your calculator. And now just for completeness, another way that you can also do it on your calculator is you first need to have it in the mode that you want to find for. And we need to tell the calculator that this is degrees. So we're going to hit the math button. We're going to move over to DMS. And then we're going to go to 1 for degrees. So now we just told the calculator this is 15.96 degrees. And when we hit enter, it's going to convert that for us to radians. So you can see here 0.278 or 0.279 radians. So for this question, for this wavelength of 550 nanometers, we will get an angle for the first order of 16 degrees or 0.278 radians.